Unit 5, Calculus, Day 39 Notes, Part 2. So now you have a cubic function, f of x. There's the cubic function. Determine the intervals where f is increasing and decreasing. Well, I know a function is increasing when the derivative is positive, and I know a function is decreasing when the derivative is negative. So I got to take the derivative. I got to find the zeros, because that will be our max and mins, or where it's undefined. Top of, again, max and mins, whether it's a cusp or a corner. And then I can use a sign change chart to determine when it's positive, then the function, if when the derivative is positive, then the function's increasing, and when the derivative's negative, then it's decreasing. So let's take a look. So take the derivative, got right there. Now I want to set it equal to 0. I want to factor it, so I took out a negative 3. And now I can factor that quadratic to x plus 3 times x plus 1. So set the three things equal to 0, and I know negative 3 will never equal 0. So x equals negative 3 and x equals negative 1. So now we use a sign change chart. Let's pick a number, I don't know, negative 5. Um, put that into the derivative. So I have negative 3, which is negative. Negative 5 plus 3 is negative. Negative 5 plus 1 is negative. So odd number of negatives, that's going to make this negative. Let's pick negative 2. So negative 3 is going to be negative. Negative 2 plus 3 is going to be positive, and then negative 2 plus 1 is going to be negative. Hey, those even number of negatives is going to make it positive. And then lastly, let's pick x equals 0. So I'm getting negative 3 is negative, 0 plus 3 is positive, 0 plus 1 is positive. So odd number of negatives makes this whole thing negative. So what does that mean? Well, I know it's increasing on the interval when it's positive, so it's going to be, let me write this down. Okay, and in blue, f of x is increasing when it's positive. That's from negative 3 to negative 1 in between there, and then it's decreasing when x is less than negative 3. That's supposed to be less than, and when x is greater than negative 1. That direction and that direction. Okay, next, determine the coordinates of the relative extrema. Justify your answer. So, hey, I know, first of all, I have to find where the min and max go. Negative means it's decreasing, then increasing, so I know that's going to be, this is going to be relative min. And then I know at 1 it's positive, negative, which means increasing, then decreasing, so that's going to be a relative max. And then to find the coordinates, I just have to substitute those back into the original function. Okay, so again, we talked about the max being at negative 1, substitute negative 1 into the original function, and we get 6. And again, why was it a max? Because the derivative goes from positive to negative. The relative min's at x equals negative 3. Why? Because the derivative changes from negative to positive. Substitute negative 3 into the original function and get 2. Okay, let's look at the diagram down below. Um, so picture below is a graph of the function on the interval from negative 4 to 1. Let me get rid of the shade. Okay, so now what we want to do is from negative 4 to 1, negative 4 to negative 1, let's find the absolute max. So, and I put the interval there so that I find that the absolute max is going to be negative 4 and positive 6, and we're going to have 0.16 there. Now let's find that absolute minimum on that interval. And hey, that's going to occur right there, and that is negative 3 to 2. Now, pay attention because they changed the sign. So now our interval is going from negative 4 to positive 1. What do I get for an absolute max? Hey, that's still in the interval, that's a max. That's still in the interval, that's a max. So it's going to be the same exact absolute max, negative 4, 6, and 1, 6. And now what's our absolute minimum? Hey, that's going to be way down here. And again, absolute minimum doesn't have to uh, increase and decrease. So that's 1, negative 14. Okay, let's take a look at the next page. All right, so what are we going to do? We're going to use the extreme value theorem to locate the absolute extrema of the function on the given closed interval. So the first one's from negative 4 to negative 1. The next one's from negative 4 to 1. So these algebraic results should match up with what we just did on the previous page, looking at the graph. Okay, so the first thing I need to do using the extreme value theorem is to take the derivative, and let's do that, which we did on the previous page, but now I want to, and again, we already did this, set equal to 0. Hey, we factor out a negative 3. and we set it equal to 0, we got x equals negative 3 and x equals negative 1. So as long as those are in the interval, then we can use those. So extreme value theorem says the absolute extrema must occur on one of the endpoints. So I need to now do f of negative 4 and f of negative 1, and then any points within that interval that make it go to 0 or are undefined. Negative 1's already counted, but now I want to do f of negative 3. And let me just write what the original function is here. Oh, I don't need to write it. It is right here. So we take this original function, substitute in negative 4, put in your calculator, whatever you need to do, we get 6. Put in negative 3, we get 2. And we put in negative 1, we get 6. So from negative 4 to negative 1, what's the maximum value? Because what we're saying is it has to occur either on one of the endpoints or where the derivative is 0 or where it's undefined. And we know that derivative f prime of x is never undefined. So I know the highest points are, hey, negative 4, 6, and negative 1, 6. So those are the largest values of the function. So that's my absolute max. And now I know my absolute min must be at the lowest of these, and that's going to be at a negative 3, 2. So if you turn back to the previous page, you'll see that's what we got for the answer when our interval was between negative 4 and negative 1. Okay, so we're going to do the same thing here, except now we're changing our interval. We're still using, I'm not going to rewrite it, but we're using the same derivative and we're using the same function. So now I have my endpoints are negative 4 and positive 1. And then, hey, where did it go to 0? At negative 3 and at negative 1. So I have 4 potential places where absolute maxes and absolute mins could occur. Okay, and now I put in negative 4. We already put that into the original function. We got 6. I already put negative 3 in there. We got 2. I already put negative 1 in there. We got 6. Now I'm going to put 1 in here, and we get negative 14. So what did this change? What is the maximum value over this interval? So the absolute max, hey, where do the largest values of the function occur? That's going to be when x is negative 4, and that's negative 4, 6. And once again at negative 1, 6. But now, where does the absolute min occur? This occurs right here, and this is 1, negative 14. Okay. All right. Let's go to the next section of the notes, part 3.